Okay, let's take a look at section 3.1. We got a new chapter, but we're still doing a lot of the same stuff, looking at quadratic functions. So right here, 3.1 is about solving quadratic equations. Uh, a lot of this you have done in Algebra 1 when you've dealt with quadratics at that point. So let's take a look at a few things right here in our vocabulary section. The first part talks about the root of an equation. Now, the roots of an equation are the x-intercepts of the equation. Or of the function. Okay, because primarily we're dealing with quadratic functions. So if you remember, if I have a quadratic function, there are three scenarios that you may encounter. The first one is where the function will cross the x-intercept one time. And so if that's the case, you have one root. You may have, right here in this next piece, you may have a function that crosses the x-intercept twice in blue. And therefore, we have two roots. The last type is where you have no real roots, and that's because right here in green, you will notice that the parabola does not cross the x-intercept at all. So one of the ways that you could find the different roots, or at least the number of roots, is by finding the discriminant. And one of the equations for that, or the equation for that, is it's actually under the part that's underneath the radical in the quadratic formula, which is b squared minus 4ac. So if you plug in your b and then the a and the c all into that part of the quadratic formula, if it's positive, then you have two real roots. Okay, remember, if it's negative, then that means you have no real roots. Or if it's 0, then you have yourself one root. Right, so that is a little basics, kind of reviewing the root of an equation right there. Now, when you take the 0 of a function, what you're actually going to do right there, and you've done it already, is that's when you take the function itself, and then you set it equal to 0, and then you can go ahead and solve things out. So that's when you're going to take your binomials and you set it equal to 0, and then there you go. You have found your, you have zeroed the function and then found the roots. So solving a quadratic equation, how do we do it? Well, the first one and the hardest one is probably by graphing. Find the x-intercepts of the related function. Okay, so that's step one. Step two is using square roots. Now you can only use square roots it's very limited in when you could use the square roots. So it's not something that you can use all the time. It's very specific on how the problem or the equation is set up or given to you. So I wouldn't recommend using square roots, or you can't use it all the time. The next one is by factoring, and that's where you take the trinomial, or it could even be a binomial, and you'd be able to factor it out, and then you use that zero product property, where we said we take each binomial or each variable and we set it equal to 0. There's also another way of solving a quadratic, and that's by completing the square. That's not listed, but we'll talk about that later on. Continuing on forward, right here we have the zero product property. In words, it says if the product of two expressions is 0, then one or both of the expressions equals 0. So if we have the expression a times b is equal to 0, it's saying that either a or either b, one of those two has to be 0. Otherwise, you're not going to get 0 as an answer. Remember, anything times 0 is going to equal 0. 1 million times 0 is 0. I could have 0.5 times 0. That still will get you 0. So let's get down to the heart of our problem here. Let's take a look and start off with number 1. It says, in the exercise, we're going to solve the equation by graphing. So what I put there in red, and to make you guys remember, is you need to start off and let's set the equation equal to 0. Now, on number 1, it's already set equal to 0. However, on numbers 2 and 3, it's not. So if you're going to try to factor and solve, which will be necessary on some of these problems, the only way you could do that is by setting the equation equal to 0 first. And if you don't, then you're not going to get the right answer. So on number 1, if we take a look at the equation, it's already set equal to 0. So pretty much what we have to do is let's figure out, instead of just randomly choosing numbers, right, figuring out where what numbers to choose and where does it cross the x-axis, the first thing that you should do is remember, in order to factor a trinomial, especially if the a term is 1 right there, is what are factors of 24? Okay, so you may have seen this right here. The x means multiply or factors of 24 that equal to negative 11. There's only one combination that works, and you have to figure out what that combination is. So if you go through the process and say, oh, you could always try 24 and 1, that does get us 24, but 24 plus 1 does not get me the middle term, which is negative 11. So that's no good. So we got to try again. Then you can try 6 times 2, or sorry, 6 times 4, which gets us 24, but 6 plus 4 does not get me negative 11. So we keep trying. Now, if you notice, we have to get negative 11. So the combination that works right here is negative 8 and negative 4. Or sorry, negative 8 and negative 3. Because negative 8 times negative 3 gets me positive 24. Negative 8 plus negative 3 gets you that negative 11. So right here, the binomial that works is x minus 8 and x minus 3. So we go ahead and have that, and then you set this equal to 0, and then x equals 8, and then you take x minus 3 equal to 0, and you'll get x is equal to 3. So those are your two solutions right there. Those are your two zeros. So let's go ahead and graph that out. Go ahead and make my axis right here. My a term is positive, so I know it's going upwards, so I can go ahead and make the x-axis a little bit lower. All right, so let's start off. Actually, because I know it's going upwards, we should probably move this up a little bit higher. And let's put it right around here. So let's go ahead. I'll plot right here at 1, 2, 3. There's one of my x-intercepts, or known as roots. And then 4, 5, 6, 7, 8. There is the second root. Now what I need to try to find right here is pretty much where the vertex is. It says solve the equation by graphing. The thing right here is that if you could factor this out, then why even bother graphing? But you guys should know how to graph this. And so if I want to find the vertex, remember you could use, it's going to be in between the 2 points. So I could go ahead and take 8 plus 3, divide that by 2, and that will get me 11 over 2, which is 5.5. So let's go right here. So this is 3, 4, 5, 5.5. This blue dotted line right there, remember that is your axis of symmetry. Always an equation, and x is equal to 5.5. So somewhere along here is where my vertex will be. So the last thing is take your 5.5 and plug it in to the equation, and then you'll be able to try to come up with your value of y. So if you take 5.5, we square it, minus 11 times 5.5 plus 24. And remember, instead of having set equal to y, if this is an equation of a quadratic, then we could change that 0 into y, because that's what initially is there. When you set it equal to 0, set y equal to 0, you can find your x-intercepts. And that's something, remember in Algebra 1, or sorry, even in geometry, when we talked about lines, to find the x-intercept, you set y equal to 0. To find the uh, y-intercepts, you set x equal to 0. Okay? So when you go ahead, we get this right here, and then y ends up equaling, looks like negative 6.25. So we'll go down 1, 2, 3, 4, 5, 6.25 happens to be something like right around there. And there is our function. And honestly, when we solve it, we actually solved it by factoring. And we found what the answers are. It's actually x is equal to 8 and 3. So there's graphing. Probably not the most effective method of solving these out. It doesn't always work nicely, especially if it doesn't cross the x-intercepts nicely. So that's why there's always other ways for us to solve things out. And that's by using the quadratic formula. But we don't have to use that in this section. Okay, so let's move on. Next up, solving equations with square roots. Now, solving equations with square roots is pretty simple. The first off is that you have to have some exponent or variable squared. And then if I take the square root of t to the second power, remember, this is actually, you take the exponent and divide it by 2. So 2 divided by 1 is 1, so you got t to the first, or t, and then you take the square root of 400. Now here's the trick, or here's the main thing that people forget. If you put 20, you're wrong, because when you take the square root of something, you should have 2 answers. So what's my second solution? We can go ahead and put plus or minus 20. Remember, the reason for that is this. In this equation, t squared, if you take 20 squared, that will get you 400. If you take negative 20 and you square that, you'll also get 400, because negative 20 times negative 20 is equal to positive 400. So that part right there is important. Take a look next up at number 5. Step 1 is not square rooting. Okay, that should always be your last step, and when you have everything isolated. So right here, we don't have the variable isolated, so let's move the 19 over by adding it to both sides, and we now have 100. At this point, we can't do anything. We can't subtract the 2k, we can't subtract the 3 to both sides. So what do? This is where we square root both sides. And now I have 2k plus 3 is equal to plus or minus 10. Okay, not just 10, but plus or minus 10. So let's begin by subtracting this and simplifying this out. We got negative 3 plus or minus 10. So we subtract 3 to both sides. And then finally right here, we'll divide both sides by 2. And we have now found what k equals. Use your order of operations. We should have, looks like 2 roots, right? The reason being is because let's take negative 3 plus 10. That right there is 7. And then we have 7 over 2 as one of the roots. You take negative 3 minus 10, and that will get you negative 13 over 2. And there you have your 2 roots. So that's how you will use the solve equations using square roots. Okay, so let's go to number 7. Let's solve this by factoring. Okay, once again, we have a trinomial, and I'm looking at this, and I have my equation. And remember, let's go ahead. It's set equal to 0, so that's good. And now let's go ahead. We got to take what are the values of the c term or factors of the c term that add up to negative 12. All right, so that's what you have to figure out next. And hopefully you got what I have right there. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So we go ahead, we take our binomial, we'll set it equal to 0, and x is equal to positive 6. You could solve it twice. You can see that there's two binomials, but they both get you the same answer. So what that means is that there's only one real root, meaning the parabola is actually only crossing the x-axis at one point, and that right there is at 6, and it's doing something like that right there. All right, so we solved that out pretty easy. Let's take a look next up at number 8. Now right here, it's not set equal to 0, so that's something you're going to have to do. So I like to try to keep the x squared positive. Whenever possible, it's probably best to try to keep that positive. So I'll subtract 14x to both sides and add 40 to both sides. And so now at this point, we can go ahead and factor this out. Factors of 40 that add up to negative 14. Easy, right? Hopefully you realize x minus 4, x minus 10. So negative 4 times negative 10 gets me 40. Adding up those two, negative 4 plus negative 10 is negative 14. So there you have it. We set it equal to 0, and x equals 4, x equals 10. And there you go. Let's take a look at number 9. Now with number 9, it's not set equal to 0, so let's do that first. I'll add x squared to both sides, so this will now become 6x squared, and then I'll do the opposite right here, subtract 4x to both sides, and end up with plus x minus 1 is equal to 0. So now what do we do this time? Because my a value is greater than 1. When it's greater than 1, I could solve this out like what I did in number 7, number 8, number 1. But when the a value is greater than 1, that adds a new twist, another curveball to the question. And what the easiest thing to do is start listing factors. So let's start off and let's list factors of 6. And what I like to do is do it right down below. So I could try factors of 6, and that's 6 and 1. I've got factors of negative 1, and we could do 1 and negative 1. Now here's what I'm going to do. I have to check. Now what I'm doing is I'm multiplying the outer and inner terms of FOILing. So 6 times negative 1 is negative 6. 1 times 1 is 1. This right here adds up to negative 5. What I needed to add up to is positive 1, that b term. Okay, so it's kind of pretty similar to all the previous problems. So that doesn't work out. We got to go back to the drawing board. So another option we have right here is let's try 3 and 2, because 3 times 2 gets me 6. And then let's try negative 1 and positive 1. I multiply this way, I end up with 3. I multiply the other diagonally, and I got negative 2. This right here adds up to positive 1. And guess what? My b term right there, and what I need is a 1. So this happens to be the correct factor combination. Now what do I do next is also important. Let's go ahead and write my binomials. So what students oftentimes mess up on is they think that the diagonal is, the two numbers diagonally is what you use for your binomial, but it's not. It's going to be the ones that are straight across, and that's something from Algebra 1 that you should have. So 3x minus 1 is one of the binomials, The other is 2x plus 1. And that's the second one. And we set it equal to 0 right here. All right. So we have that set equal to 0. And then now you can go ahead and solve things out. And let's go ahead. We use that zero product property. 3x minus 1 is equal to 0. 3x is equal to 1. X is equal to 1/3. Take the 2x plus 1, set it equal to 0. 2x is equal to negative 1. X is equal to negative 1/2. And now we have our two solutions. All right, so if you need some more practice, one of the things to look at is factoring when the a term is greater than 0 or greater than 1. And that's something that you could look for maybe in Khan Academy or also come to tutorial. All right, let's take a look at the last type of problem right here and our good old word problems. Okay, once again, word problems or story problems you may see on the test or quiz. So it's important to make sure that you have an idea of what's going on here. Okay, a skydiver right here falls out of an airplane that's flying at an altitude of 4,624 feet. So it says let's use the formula that's given right here. And if you think about the formula, my a term is negative 16. Okay, so what that should hopefully have you understand is that I have a downwards parabola. Okay, bottom line, my parabola is going downwards. When they have in the equation h sub 0, so when it's sub 0, that usually tells you the initial height or the initial point. In this instance, it's h represents height, so h sub 0 represents initial height. Okay, so it's where the skydiver is starting from. So they're out of an airplane, and most likely at the airplane, it's going to make sense that they'll probably be right here at the vertex, right? When they jump out of that airplane, that is probably the vertex of this parabola or quadratic function. Okay, so it says use that formula, gives the skydiver height h during the free fall t seconds after the skydiver drops out of the plane. So I know right here that they gave us an altitude of 4,624 feet. So that right there, we have to figure out where does that belong in my equation. Well, hopefully we realize that that is going to be the starting point because that's where the person drops out. So where does that put us? It's going to be 4,000 or negative 16 t squared, and then plus right here, let's go ahead, 4,624 feet. So if I look at my diagram, it's actually not very accurate to what's going on right here. Because remember, what does this represent? We talked about it in some of the problems that we went over in chapter 2, and I made a mention of it in chapter 1 as well. But in this quadratic function, this right here represents, that's your C term, right? And if it's your C term, in terms of the graph, this is your y-intercept. So if I look at my diagram right here, this right here isn't accurate. What do I need to do? My y-intercept should be right there. It's so that right there is your 4,624 feet. And then it's jumping down either left or right. Okay. So now the last problem says, part B says it is possible for the skydiver to wait 18 seconds before pulling the parachute cord. I think it should be, is it possible? Obviously, there looks like there's a mistake in the book. But is it possible? Well, how am I going to figure that out? Okay. Well, they give us time, so there might be a good spot for us to try to figure out. All right. So let's see what happens. Uh, is it possible? Okay. Well, we have our equation. We have height is equal to -16, and then we have time as being 18 seconds. We have the rest of the equation as plus 4,624. So let's figure out what the height is. You could use your calculator. And right here, I get height as -560. So let's use some common sense right here. Hopefully we realize that the x-axis is the ground. It's saying that at 18 seconds, so most likely somewhere over here, this is where x is 18, the person's down here at -560. That's no bueno. Hopefully that means that this person is most likely either severely injured or possibly dead. So should the person wait 18 seconds? This would be a big no. Unless this person wants to be a pancake and a statistic. So this one is no. All right, is it possible? Yes, the person can wait 18 seconds, but by the time that thing deploys, it's going to be bad news. So one of the cool things that you could also find out algebraically is, well, at where exactly, what point can this person figure out, or where can they end up, like how much time can they have before they deploy their parachute? And remember, what I care about is when is height 0, okay? So what you could do right here, the last part, and this is a little extra bonus, but if height is 0, that's ground level. If I go ahead and take my equation right here, you set this equal to 0, and then we go ahead and work our way of solving for t, you could figure out exactly how many seconds. And what you'll find is that in 17 seconds, that's when the skydiver, that's the most amount of time this person should wait. But most likely wouldn't even want to wait that long, because I don't think a parachute will save him and slow him down enough if he waits somewhere around here in our diagram to open up. All right. So, but definitely, this kind of is a basic way of showing you, hey, how does quadratics work and how we could apply that to some real life scenarios. And there is the end of 3.1.